This is FP3 June 2012, question 3. Now, question 3 is a differential equation question. It's dy dx plus y cos x equals 2x. So, FP3, question 3, June 12. Now, differential equation we have to solve is dy dx plus y cot x equals 2x. Now, this differential equation is in standard linear form, dy dx, y times some function of x equals some other function of x. So we're going to use an integrating factor to solve it. Now, my p of x in this situation is cot x, so my integrating factor is going to equal e to the integral cot x dx. Now, if you look up in the green book, the integral of cot x is ln sine x, so that's e ln sine x, and we see immediately why they picked this. A lot of these questions are relatively contrived, and that integral of cot giving me an integral of giving me ln sine x. E to a natural log is just sine x there. So what I'm now allowed to write is that d dx of y sine x equals 2x sine x, and that's by the miracle of e enabling an integrating factor to just turn a relatively complex differential equation into the derivative of a product here, and which is going to be relatively easy to solve. And I'll integrate both sides of this, and integrate the left hand side. I get y sine x equals integral of the right hand side 2x sine x dx. Don't forget those dx's. So I'm mark scheme today where there's actually a mark for putting the right dx in there. That was dt at the time. Now, that's okay with the left hand side, that's done. This right hand side, this is a product, so we're going to integrate this by parts. So my y sine x is going to equal, now by parts, my u here is going to be the 2x, and then du is going to be 2. And my dv dx is going to be sine x, and so my v is going to be minus cos x. So, take the product of those two, it's going to be minus 2x cos x minus the integral, being very careful of 2 times minus cos x is minus 2 cos x dx, being very careful about handling that double negative there. So, that's equal to minus 2x cos x, but the integral of minus 2 cos x, integral of cos is sine, so integral of minus cos is going to be minus sine. So I'm going to end up with plus from the double negative 2 sine x plus arbitrary constant c, which I can then now at this point that's the general solution, but they gave us some specific information. They said that y equals 2 when x equals pi by 6. So I've got y equals 2, x equals pi by 6, and I'm going to use that information to find c. And I'm noting at this point that they want the answer in form y equals function of x, so ultimately I'll have to divide through by my sine x. Now, if y is 2 and x is pi by 6, I've got on the left hand side 2 times, well, sine pi by 6 is a half, so 2 times a half is equal to minus 2x here is going to be minus 2 pi by 6 cos pi by 6. I'll put that in a moment so I know where it went, but we'll simplify that in a minute, plus 2 sine pi by 6 plus c. Now that's going to be 1 equals, now cos pi by 6 is root 3 over 2, so that's minus 2 root 3 pi, so root 3 over 2 all over 12, and then plus sine pi by 6 is a half, so 2 times a half is 1 plus c. Now this is going to cancel out quite a lot, so 1 equal, I'll cancel that, is minus root 3 over 6 pi plus plus 1 plus c. Cancel those 1s and take that to the left hand side and turn it all round, and I've got c equals root 3 over 6 pi. Now, final step then is to write out my particular integral here. So I'm going to end up with y sine x then is equal to 2 sine x minus 2x cos x plus root 3 over 6 pi. Divide through by sine x, I get y equals 2, so that cancels. Cos x over sine x is cot x, so minus 2x cot x plus pi by 6 root 3, and that is the answer to question 3.